Always. Should we just go somewhere else for class?
No.
Like, it's really bad.
That's what's it called?
That's what-
You can open the door.
What's
if
this
you
way
want.
did?
No, it's too cold though.
Yeah, there was a dining hall. The
You
dining
can
hall's
open
not
it
there
right
now.
there. Just sit down.
The house smells like sweetness. I'm literally mad. I'd rather spend this on an air hockey.
Alright, we just gotta embrace it now, guys. It's off. It's like your own brand. You just gotta learn to love it. Like, Liz, like, I know exactly what it's talking about, and I love my brand, but I'm not gonna show it because that's not very ladylike.
Those are the ones who like stick their hands in the field.
Yes.
Is it true we had homework?
It is true you had homework.
I picture
didn't
Liz,
show
like,
up on my
running around like,
Sunday.
come snip.
Yes, you did.
You put it under the wrong day.
What do you mean?
Oh, you put it under.
Yeah, it was.
Well, it only is in like, you put it as an. Oh, you said what's with TV?
No, I said it was due
Hey,
Tuesday.
there's,
so
yeah,
today.
that's where I found it. There's no assignments due today.
Let me check.
Yeah, there was a
It
sign.
Yeah,
said
you
it's
put
due
it under-
yesterday.
Yeah, you put it under due for Tuesday. I mean, yeah. No, that was the stuff we wanted.
No, I put up the video.
Yeah,
Already?
Oh, yeah, I did that Monday. Oh, no, yeah.
This video.
I wish I could wrap it, and wear sunglasses inside.
So, did no one do homework last night?
I did it.
I did.
I watched the video.
I did.
Alright, so, I guess I'll do this a little bit. So, how come half, Noah, can you please stop watching the video, or whatever you're watching? How come half of you saw the homework, but the other half didn't?
Because it depends on how your sundial's set up. Like some people have it set up where like it shows them what to do that day while I go to like the specific classes.
That's a massive goal.
I was.
Yeah, I did accidentally.
Yeah.
Today's Wednesday, yeah.
Yeah, but you put on this due for what day is due on Tuesday.
Right, today is Wednesday. Oh, well, most of you watched it, right? Okay, so if you go to, when this goes up, you go to our topics board, we have, you see the introduction to chemical reactions. I want you to go there and do this warm-up activity. You can use your notes, reference your notes that you took, and submit it. So take about 5 minutes to answer these 4 questions, please. And we'll be good to go. See, it's under the topic, introduction to chemical reactions. Everyone find it? Do you want me to turn on this front light? That'd be easier. Or can you see it? Turn it up.
What is it under?
It's under topics, introduction to chemical reactions, where the homework was posted, and it's right next to it. So it's just a quick warm up, 4 questions.
This is supposed to be a quiz, but
It's just a warm, it's not a quiz, it's just a warm up to see how the homework went for you guys.
alright, it's under chemistry, topics.
Topics, yep.
Introduction.
And then just submit it. That would be good. What? What are, which question? Yeah, physical properties. submitted it? If everyone's done, we can just. Has everyone completed it? Yes? Let's see. I have just 10, so I need 4 more people to submit it. Getting closer, 3 more.
So those are the change, now they look at it, no, they're wrong.
What was that?
Someone like pick physical change on that question, like now they're probably looking at it like, oh, like, totally shit.
That's okay. That's why we're gonna go over it.
So pick physical change.
Alright, so submit your answers now,
Yeah.
please. Oh, one more. We're almost there. Oh, good. Okay. So the first question, which of the following is an example of physical change? We have 13 to 1. So it's either between a glass cup falls from the counter and shatters on the ground, or lighting a piece of paper on fire and the paper burns up and leaves ash. Now, which one is correct?
The glass,
Why?
because the fire is.
She literally breaks it.
Right. So what are we doing when it falls? We're just changing we're changing the physical property, right? The shape, maybe the mass and the different size of the pieces. Now, lighting a piece of paper, that's a what? What kind of change?
Chemical.
Chemical, and how do you know that?
It's changing the temperature.
Because it changes, it's like, it's,
Can you repeat that louder? Changes its properties, and we're left with what? Ash, a new substance, right? Alright, so now the second one kind of answers, when the new substance is formed with different properties than the original substance, it is called a what? Physical change or chemical change?
chemical.
Chemical. Can you explain why? Owen?
Why?
Why it's a chemical change rather than a physical change?
What was it the one
This one, number 2.
Because it's substance, like changes.
Because what?
Because it like changes, like property.
Does the physical properties change? Anything else? Anyone else know why?
Substance.
Is the chemical change really when a chemical property change?
No, not necessarily. The new product will have its own physical properties. It'll be both. So
Well, for the first one, when you drop a glass cup, technically, are you changing its physical properties? Like
We
you're
are.
changing the size.
yeah, we are changing the physical properties, but are we getting a new substance altogether? And when we drop the glass, it's still glass, right? It's just its appearance is different. Whereas this one, we're getting a totally new. The product is a new substance in itself, so that's how you would know it's a chemical change. And which one of these is an example of a chemical change? Water freezes, wood is cut, wire is bent, bread is baked. So the majority of us is right because bread is baked. But why is water freezes not a chemical change?
Nothing's being solid.
Can
It's
you-
the same substance, it's just in a different form.
It's just different, right, solid, different form, different state. So it's the same thing, it's still hydrogen and oxygen, just a different presentation. And now the last one, if the chemical composition of a substance remains unchanged and the appearance or shape of the substance changes, it is called a what? Physical change, right? So when we have some disputes, we have physical change, both chemical and physical, and neither.
No, the composition of the substance remains unchanged, so it can't be a chemical.
Right.
It can't be neither a chemical or a physical, because there's a change,
Right?
Yeah.
so it's a physical.
So
Yeah.
it's physical change.
I was gonna put neither, but then I was just like, that sentence sounds too weird if I had neither.
Yeah. So how does everyone feel about this? Just a check-in on how the homework was.
Pretty good.
Pretty good? Alright, so now I'll go turn the lights on. Nick Belknap. We're gonna review some of the terms that were in the homework and go in a little bit more detail. Because today and Monday kind of,
Not exactly right.
we started a new unit. We started chemical reactions.
Oh, snap.
I know, we get into the really exciting things as we saw with the iron sulfur lab. So since we learned previously how to write chemical formulas, how to name compounds, we can move into chemical reactions, being able to observe them, describe them, things like that. So first though, in order to there we go, write chemical equations, chemical reactions, we need some groundwork. We need to be able to, can I turn this off? There we go. I know the smell, but I think you'll be able to deal with it. You'll get used to it eventually.
Just to make it stronger, because there's no ventilation.
This is no ventilation yet, but you'll be okay, I promise. So we have to go over the kind of the groundwork in order to recognize a chemical reaction and how to describe it and things such as that. So the homework, what did it review? What did the video go over? What two major categories? Physical and chemical change. So let's start with physical change. Who can, in their own words, you can look at your notes too, describe to me what a physical change is? Anyone?
It doesn't change any chemical properties of it.
Okay, very good. Physical change.
Like, it doesn't change the makeup of atoms.
Right, so good. So we said does not change. I'm going to say composition. Is that okay? Composition of a substance. And Dylan, what did you say? I liked what you said. It only affects physical properties, right? And as a review, I'm going to write just props, but you know what that means. As a review, what are physical properties? Right, those are examples. So, what do we use physical properties to do when we're talking about something? You're right, mass. Describe, right? So, describe a substance. And as Phoebe said, an example, you could say the mass, or the color, texture, density, things like that. So how do we feel about physical change? Pretty good? So now on the other side of things, what is a chemical change?
Well, it produces a new substance.
It produces a new substance, yep. Anything else? You can look at your notes though.
It produces into a new substance.
Yeah, that's what Doug said. Anything else?
It changes like the chemical makeup.
Yep. So we could say, you observe how a substance reacts with another substance. To produce substance. And I know that's like 3 substances in one sentence, but another way to look at it is if I wrote plus B yields C. So what are A and B called? What would we call those two substances? Does anyone know? Bases? No, not bases. What are they gonna do to form C?
Mixture.
Mixture bond. They're called reactants. So A and B are reactants. And what is C called? If we have two reactants,
The reaction.
well, C, this would be the reaction. C would be
Product.
product. Very good. And this is a product. And I was thinking about it. Chemical change and chemical properties are it's kind of redundant. Did you guys get that same kind of feeling when you were watching the video? Because what did we say a chemical change was, or a chemical property was? Anyone have that in their notes? You can look in there.
Describe how a substance reacts with another substance to produce a new one.
Right. So just to give you more of a, to distinguish between the two, a chemical change is observing it's observing what is happening when a chemical property is taking place, where a chemical property is describing that chemical change. Is that kind of clear that up for you? So they go hand in hand, just like physical change and physical properties go hand in hand. So let's do, property. Pretty much the same thing. A chemical property is describing how a substance, how we can now, because we know the word reactants, how reactants will be products. And also in the video, we had a list of ways you could tell if a chemical change occurred. Does anyone know any of those?
Like bubbling, change in temperature,
Very good. So evidence.
change in color.
My marker's not working. Evidence. Can you guys see it over there? Everyone can see this?
Yep.
Okay. I need the color. Alright, what was one, Sean? You said
Boil or bubbling,
bubbling, which was also, so bubbling,
change in temperature.
bubbling, which is production of gas. Is that spelled right? Are there two P's in bubbling?
Yeah.
Production. Gas. Change in color. Very good. Someone else tell me another one. What else was there? Not you, Sean. You're doing great. I want someone else to.
Change.
What's up?
Is this from the what, the balloon one?
Yeah, and it was one of the last slides. Yep, that was that's how you could identify that, and that was an example of what? When the balloon inflated.
The chemical change?
Right, which was the production of gas, right?
Yeah.
Because we could actually see it. Done.
Evaporation. Every one.
That could be one, evaporation, yeah, but that would also be production of gas kind of, right?
I have formation of a precipitate.
Right, formation of a precipitate, good. Formation, 1 second. So a precipitate is kind of like a solid that will form when a reaction occurs. And one more. What was the last one? Alex, do you know? You have any notes? what?
Light.
Alright, production of heat. I want to change this from production to change. Change in heat or light. Because a reaction can occur if heat increases or there's light, but it can also is present if the temperature decreases. And those for reactions that deal with heat and light change, there are two different names. We have endothermic, and you want to add this to your notes. An endothermic reaction.
Where should we add?
To the notes that you took last night on the video. You
Yeah.
can add it to underneath evidence of chemical change if you want. So an endothermic reaction deals with when the temperature, the energy or heat is absorbed, so the temperature will decrease. Decrease. And the way I think about it is N is in, so it absorbs it in, so the temperature will go down. And then exothermic is when energy or heat is released. So temperature will go up. And exo is kind of like out, so it releases. Anyone have any questions on that? No? How do you feel about this material? Okay? Well, we're going to see how well you can put this knowledge to use. We're going to do some demos, and you're going to tell me whether, that's just the heat, don't worry about it, whether it was a physical or chemical change. Okay? So once you're done writing your notes, please go pick up a whiteboard and a marker and a clock.
Just do it. I don't want to see back
So you can use your computer for notes if you want, but everything's up there too. So the first one, I have this apple, right? I'm going to take a bite out of it. What kind of change?
Physical.
Do I want you to write it down? Don't shout it out, please. Good. And why is it physical? As I finish. Right, I'm changing its size, it's still an apple, right?
Yeah.
Alright, so the
Do you have
next one.
double-sided board so I can write physical on one and chemical on the other? I can just flip them.
Alright, that would be,
Oh, I got an idea. I'm gonna put physical up, then I'm gonna put chemical like that.
that is very
Yeah.
thinking.
I already took that.
So next, I need someone to come help me to do this demo. Who wants to help?
I do.
Alright, come up here, Sean, please.
Hold on.
Ms. Ferreira, can I ask a question?
Yes.
So, was there a chemical change in that?
In her belly,
Yeah,
possibly.
I was gonna ask that next. Yes, in my belly. That is true.
Oh, sweet.
So what I want you to do is, here's my book.
Oh.
Here's the wheel. I want you to mass out, this is ammonium nitrate, about 25 grams of that, please. So ammonium nitrate, since we know about, or we know how to
Does this stuff
write
smell bad?
formulas, no. It is really good. What would be the chemical formula for that? Ammonium nitrate. Anyone know? Anyone want to write that down?
Wait, what?
Ammonium nitrate.
How many grams?
25. Please write that down. Ammonium nitrate. Write down the formula.
Where, in between physical or chemical?
Anywhere you want, and then you can erase it. I just want to see what you know. Well, Sean's being a fantastic helper.
Not like letters, dude, on your periodic table. Not just like write out the word ammonium
I was
nitrate.
gonna write it out, and then I was gonna get the period out.
These are really clumsy. I'm sorry.
Ammonium.
You're doing a great job. So what do we have? Someone have the answer?
NH4CO3. Is what I meant.
Is that correct?
Yep.
Yeah.
Nitrate.
Good. And what kind of compound is this? Ionic, right? Very good. So while Sean's doing that, I'm gonna, very good. Now pour that into here, please. I'm going to measure out 65 milliliters of deionized water. Henry, can you stop talking? Christina, you too, please.
Yeah, can see that.
There's two lovebirds back there.
Alright, so that's it.
Ridiculous.
Now I would like you to pour that water into the bag and mix it up. Be careful, don't spill it. Seal it up, please.
Oh, sorry. Yeah.
Now mix it.
And this thing.
Oh no, you can just mix it like this. What do you feel happening?
Nothing.
Nothing?
It's getting squishy.
Getting squishy? Does it feel hot or cold or anything?
Cold. But the water was cold.
Was the water really that cold?
It's really cold.
This is pretty cold, I'd say. I'm gonna put it in here so it doesn't spill. Thank you, Sean. You may sit down. Can you put your goggles on? Thanks. And I want you to tell me whether you think it's a chemical or physical change.
Chemical.
Chemical. I want you to write it down and not say it. Shout it out.
Chemical.
I want you to write it down and not say it.
I did, I wrote it, and then I
And then you said it. So.
Pass it around.
carefully developed logo.
Alex? Abby, did I see you?
Wait, what is that stuff called?
Ammonium nitrate. And we use just regular water. It's freezing, right? This is how you actually make an ice pack. Hey, boys, can you stop talking, please? You know when you get injured in a game and the trainer will break open or
Icy
will
hot.
pop the ice pack? It's actually ammonium nitrate and water, and you're breaking the boundary between them, and that's how it happens. So we said this was a chemical reaction, right? Explain why. Tell me how you know that.
Change in temperature.
Change in temperature, right? That's one of our indications. And what is this, an endothermic or an exothermic reaction? An endothermic, very good, because what happened? Right, so that shows that the energy was absorbed, right? Pretty cool, huh?
So when it absorbs heat, how does the temperature go down?
What?
If it absorbs heat, how does the temperature go down?
Because the energy that it takes to, when the reaction between it, let me see. So if it was releasing heat, it would be warm, right? Because it would be releasing, but the energy is going in, not so much
it's like
heat,
trapped
but
inside.
the energy is, yeah, is being used to produce this. So if you see,
It's like fried chicken, it's like, you don't really think it's that hot on the outside, and then when you take a bite out of it, it burns your tongue. It's like,
kind of like hot chicken.
That's
fried
actually
chicken.
spot on.
Spot on. Okay. Next, I have a piece of paper. If I rip the paper, what kind of change is that?
Physical.
Don't,
Scream it
please
out
do not
again.
I didn't yell it out.
That wasn't you that time.
Correct.
I know. And why is it physical?
Holy fire. Right at, right.
Tell me, everyone, show me, please.
That's gonna be chemical.
Physical, good. It's still paper, right?
Yeah, it's gonna be chemical though. Whatever you're about to do with fire is gonna be chemical.
If I now burn it,
Chemical.
It's like wood. Being burned. Same thing.
and this is water. Don't get. That is chemical. Very good. And how do you know? What evidence do we see?
Change of heat.
Color.
Change
Colors.
in heat, color,
The gas.
produces a gas. Good. And what's our,
The substance.
not precipitate, a new substance. What's a new substance? It's no longer paper. It's ash, or, the middle is now all the way burned through, but the outside is ash, right? Very good, let's see. Okay, can you see, it's not done yet. Can you see right there on my apple?
Chemical.
Chemical,
Why?
because it's oxidizing.
Very good, it's turning brown. It's like rust on your apple. Can everyone see that?
Gross.
Gross. Alright. I need another helper. Who wants to come help
Henry.
me?
Christina does.
Henry
Phil.
does.
Awesome.
Can you come help me, please?
Sure.
So I have some water. Here you go, sir.
If they'll not strike out on them, but I'll try to.
And while we were doing this is potassium iodide. I want you to write on your board. Henry, stop
I
talking.
need to get my marker.
I want you to write the formula of potassium iodide, please. Put 2 scoops in here, and then I'll
What
put
is
you
it?
stir around. Potassium iodide. Nope, just put 2 scoops right in there. Iodide. Good question. That might be good, just fine like that. Good. Yep. And now mix it up. So what Phil is doing right now with the glass, he put iodide. Very good.
So the 2 Ds, not a D and a T.
Right, 2 Ds. What is Phil doing right now? This is a chemical or physical change.
What did he do?
He put the potassium iodide in the water, and now he's stirring it. It's dissolving.
Physical. Physical.
Physical. Explain why. I need some more explanation.
It's not changing the actual whatever it is. What was the water?
Potassium iodide.
It's not changing the potassium iodide. It's changing the appearance of it.
Right. Very good. Now, Phil, do you think you could carefully pour this in here, or do you like
Yeah.
All right. Very carefully. Do not spill. Please pour that in there.
How is that not a chemical?
How is that not a chemical change?
Dissolved.
Because it's just dissolving, right?
Isn't that chemical?
No, dissolving's not change. It's not. It's just changing the state again, right? It'd be a solid to a liquid solution. It's a mixture, right? Thank you, sir. You're all set. Yeah, give him a round of applause. Now, this is lead nitrate. I'm gonna pour a little splash into here.
Just a little splash.
A little splash.
Ooh.
Whoa.
How cool is that?
That's
Chemical. No, I can put more. So now what happened? Write down chemical or physical. Please.
Chemical. Change color.
Good.
What is that stuff?
What is what?
Stuff that you put in.
I poured lead nitrate in. So why is that a chemical change?
Changes in color.
Changes in color and what else?
It's like money.
It is like muddy, and this is what a precipitate is. If you can see it, if you look kind of closely, you'll see it. There's like a solid form. It's like little chunks.
If I were to drink it,
Huh?
if I were to drink it,
It's lead, so you know, like lead paint is not
I
good.
just die.
You don't want to drink it now. That's why. All right, so that's what have we seen for chemicals so far? far?
Changing colors, formation of a precipitate, changing heat, absorption of temperature, and releasing of temperature.
Very good. So now, this is
Everything but
water.
bubbling.
So how do we see a change in
And
light?
light.
Yeah, how do we see a change in light?
What do you mean? Well, when I burned it, light was produced,
Oh.
not
Light
changes.
is fire.
Well, there was no light and then there was a flame kind of thing. So this is just water, and I'm gonna boil it. Hopefully, it'll boil. And I need one more person to come up here.
Do it, Noah.
Noah, you wanna come help me? Great, thank you. I need you. Oh, and there's another balloon. Can you grab it for me? Please? I need you to carefully put a couple scoops of baking soda into that.
I'll mess up.
You got it. It's okay if you make a little bit of mess. Just do it over here so I can clean it up.
How many?
Just a couple. Sure, 3 is fine. And I'm gonna pour some vinegar, which is right into here. Alright, so now what I want you to do is to do what I did with this balloon and put it very carefully over the mouth of the flask and then tip it. Please, and I'll hold it for you. Just watch your hand, this is a hot plate and it's on. You're not wearing your goggles, sir.
Yummy, just put the.
Thank you.
Safety.
Safety always comes first, right? You got it? There we go. Now lift the balloon up and tip all that baking soda in.
Gas is produced.
Gas is produced.
Bubbles.
Thank you.
This might explode
Bubbles.
in my face.
It will not explode in your face. I'll make sure it will not. Very good. Thank you, sir.
No, let it explode.
I wonder if this, if I waited too long.
balloon.
I'll try this bubble. So we have another, just like the Alka-Seltzer, same kind of thing is produced, right? Or happens. So this is the production of
Gas.
gas, right? I think we've hit everything. I'm hoping this, I waited too long. I'm gonna boil this. We'll wait for that. And did I do all of mine? I did all my demos. So how do you feel? Do you think you'd be able to, if I gave you like a list of reactions, you'd be able to determine if it was a, or changes rather, if it was a chemical or physical change?
Yeah.
Yes.
Yes? You say no?
Yes.
Oh, yes.
Are you
So,
gonna have a quiz?
when we did our, not today, when we did our iron sulfur lab, what did we see there?
Chemical change.
And how? How did we see that?
When the silver was like burning in the fire. Yeah.
And change of color. What color was produced? Red, right? And then also you said one more thing, Olivia.
Yellow. It was bright yellow as it came.
Right, the inside was red, it was really hot red when we were burning it over the Bunsen burner. So that would be light or heat. And then you said the gas that came out was yellow, right? And also, what did we say? So we have the reactants, and then the product. The product has its own unique what? What did we say? Physical properties, right? And then so once we got the product, we tested it with a magnet, and then we tested it with hydrochloric acid and carbon disulfide, right? Does everyone remember doing that? Yes. Did it have the same reaction? Did the product have the same reaction as when we just did the iron and the sulfur to those two chemicals? Kinda. What was really different about the product that everyone complained about? You complained about when you walked in here. It smelled, right? Produced a very smelly substance. But when we did it with the iron and the sulfur, that didn't really happen, right? We didn't really get a strong odor, right? Everyone remember that?
Right.
And what about, Abby, could you grab the watch glasses right there for me, please? Yeah. carbon disulfide, right? So I have okay, this is exactly what I want to have happen. Alright, so let's first talk about this. Here's the sulfur, right? Just with the carbon disulfide. Here's the iron. And then here's the product. You can kind of see a little bit of stuff, probably not from there. But we'll pass these around. Did this have a different outcome than the two reactants? Stop looking at the balloon. I know it's
It's
exciting.
shrinking.
It's shrinking, right? So did the product have a different outcome than the two reactants?
Yeah.
Yes, right? So that's another example of how the physical properties are different, right? Or chemical too. Does everyone see that? So back to this. I just want to do my last one. So we saw that I did what to the water? I boiled it, and then I had an inflated balloon. What kind of change is the boiling of water? Physical. And this is a what?
Chemical.
How come they produce the same thing? I both get gas and the balloon, not now, inflates. How come the same thing happens but I have two different changes?
Because it's still the same substance, because like steam's just water in a gas form.
Very good. So
Aren't
this is,
you changing the heat of it?
I am changing the heat of this, right?
That's just water. Right?
This is just water, yes. So hold on, let me turn
So how
this on.
come it isn't chemical?
Because the final product, or what I end up with, it's the same thing, right? So heat is a good indication of a chemical change, but it's not always, if there's heat present, it's not always just a chemical change. So like Phil said, the reason this is a physical change and this is a chemical change is a new substance was formed, right?
3 minutes.
3 minutes. So, what we will be doing in class tomorrow, do not clean up yet, please. Listen to me. You can erase your board and I'll have you put them away in a second. We will be working on the iron sulfur lab now that we know more about it. We will be writing the formal lab report in class with your groups. So come prepared. I would advise you to look it over quickly and make sure you maybe start writing some notes. And then I'll just go around and check. I will also be posting a video talking about writing chemical equations. So now that we know how to recognize when a chemical reaction occurs, we can get into writing, okay? So please put those boards away, push in your chairs, clean your desks.